Welcome! Today is our first art project day, and we are super excited to show you guys several different ways that you can make your own model of the atmosphere. It is definitely true that we learn better by doing, and hopefully you have learned a lot about the layers of the atmosphere during the first few lessons of our class, but now if you put it into practice and make yourself a model, that will help the learning go even deeper. And it's just really fun to express yourself with art.
Science Puppy's excited for some art.
Definitely. In fact, he was trying to eat one of our art projects earlier.
Makes him extra excited.
It does. Now, before we dive into our art project, there were so many good questions that we had from our students in the chat the last couple lessons that we wanted to take just a few minutes to answer some questions. And I thought it might be fun if we made them into poll questions. So today, our poll questions are questions from you guys. We'll see how well the chat in general does answering them, and then we'll show you guys the answer.
So real quick, there are questions about your hoodie, Science Mom?
Oh, yes. This is in honor of our students because they're the unbeatable, undefeatable science kids that Math Dad is very rarely able to stump with questions.
Oh, you guys are going down.
First question is about the egg in a bottle experiment that we did yesterday. So if we try right now to use a balloon instead of an egg, could we get it to work?
Wait. So what do you have there? So it's a water balloon.
It's a balloon that has water in it. That's right.
All right.
And we can't stick candles inside a balloon, obviously. Oh, and Matt, Dad, do you want to open up item pool so they can vote?
Well, we're kind of committed there if we do it, but
okay, vote in the chat if you would like. We will save the item pool for a little bit later.
Will the balloon work?
Will it work?
Not?
Yes or no? So what do you think? If we can't stick candles in the balloon, but if we light a piece of tissue paper on fire, drop it in, and then the air gets hot and we place the balloon on top, will it work? Will the pressure draw the balloon in?
Ooh, because it certainly worked for the egg. Like sucked it right in.
It did. Chris says yes. Sonica says no. Alondra says no. We've got Pickle Obsessed says no. Maurice says yes. We've got lots of different guesses coming in. Let's find out.
All right. I'm really curious. Got the matches here, Science Mom?
Yes. And I will say, if you want to try either the egg in the bottle experiment or this one, anytime you are doing an experiment that involves matches or fire, make sure you have adult supervision. And do this very carefully. So we're lighting a little piece of toilet paper. It's in there. The air is hot. Oh, it almost went out early.
Uh-oh.
It moved. Did you see that?
It twitched.
So there was a little bit of pressure and it sucked it down just a little bit. But it does not look like it was airtight enough, or maybe the pressure wasn't great enough to actually draw it in. And what we should do is an experiment. What if I just squeeze the bottle? Here, Math Dad, now put it there.
Oh, yeah.
So we know that that little balloon could fit. The question is, did the air get hot enough? My guess is that this is an experiment that would work. You could use a little balloon instead of an egg, but I think it would be trickier and take more practice to be able to get right.
Yeah.
Okay.
Oh, pretty cool.
For the next question, I think we definitely should do item pool because I'm really curious what you guys think. The next question is about this bucket because we had several people ask really good questions about how much water this could hold. If we had 1.5 gallons or close to 2 gallons, that would be about 15 pounds of water. So could 2 gallons stay in the bucket if we put a paper over the top, or not a paper, like a piece of cardstock or something kind of firm, and then flipped it upside down? Would it keep the water in?
All right.
So same link as usual, although I know we're doing this earlier in the lesson than we usually do, itempool.com/sciencemom/live. Go ahead and cast your votes for yay or nay. 2 gallons in this bucket. Would it work? And just in case someone is watching who didn't see the last lesson, I'll just say again, here's how it works. We take our bucket, we put 2 gallons in, we put a piece of poster board on top, we turn it upside down, and then we let go on the bottom to see if it stays.
Yeah, boy. That's an interesting question, Science Mom.
And it looks like we're close to 50-50.
Yeah.
So
it's not obvious.
Yeah. Some people are saying it would make a mess. All the water is going to splash out. Other people are saying that it will hold the water. Now we definitely have more votes in favor of one answer than the other. And
but I don't know which one.
I don't know which one either.
What do you think, Colin? What do you think?
And the puppy's like, I don't know why you're so excited, guys.
All right. Well, let's just see how they voted. And I think it will hold.
Ooh, most people think it would hold.
And I guess I have that marked as the correct answer. But is it the correct answer, Science Mom?
Let's find out. We actually did a video. We made a short little video for you guys where we tested this out to see just how much weight you could get to hold. So let's go back to our main view real fast.
Well, actually, you're just going to show it here.
There we go.
All right.
So can air pressure hold up 1 gallon of water? We turn it upside down, and yes, it works.
All right, so it worked for 1 gallon.
It worked for 1 gallon. What about 2 gallons? 2 gallons is way heavier. How much does 2 gallons weigh, Math Dad?
About 15, 16 pounds. Yeah.
Right about 16 pounds. I was impressed. This one totally worked.
So it did work. All right.
What about 3 gallons?
Chat was right on this one. 3 gallons. Is 3 gallons going to work? 3 gallons is getting pretty heavy,
3 gallons
guys.
is getting pretty heavy. This was, and you see a little bit of the water spilled out, but we've still got enough water there that's not easy for Math Dad to hold.
What? 3
gallons? Oh my
gallons?
goodness, it worked. I couldn't believe it.
Okay.
So all of this water, and that's a lot of water, was held in the bucket by air pressure. And it turns out that air pressure is about 15 pounds per square inch. So even 4 gallons, how many pounds is this, Math Dad?
So then you're up to 32 pounds?
32 pounds. Uh-oh.
Oh, saboteur.
5 gallons. This is a 5-gallon bucket. So 5 gallons is the most it can hold. We filled it to the brim, turned it upside down, and 5 gallons even worked for just a second before our poster board failed.
Couldn't hold the weight.
So with 5 gallons, here's my question for you guys. Was gravity stronger than air pressure? Is that what's going on with 5 gallons?
That's a good question.
And it turns out that 15 pounds per square inch, well, 14.7, that's what air pressure is at sea level. And if then you're higher elevation, it's going to be a little less. Where we live, it's about 13 pounds per square inch. And now let's go back to this main view, Math Dad, real quick. And this is a lot bigger than a square inch.
It is indeed a lot bigger.
So this will work as long as you have a flat container, because that's really key. If you have any little dip where air can get in, it's not going to work. You need to have a flat container, and you need to have something that's stiff enough to hold its shape. If we took this bucket and we put a towel over the top and then turned it upside down, it's not going to work because the towel is not going to hold its shape. It's not going to stay flat as it has that dual pressure against it, because that poster board, it was experiencing the force of the weight of the water pushing down, and it was experiencing the force of the air pressure pushing up. And if it's something like a towel that can bend, it's just going to deform. But if it's the poster board or like a piece of plastic or something that's stiff, then it will work and it will hold the water in. It turns out if you had a pipe that just had an opening that was 1 square inch in area, it would have to be about 33 feet tall in order for there to be 14.7 pounds of water on top of it.
Wow, 33 feet tall.
So in theory, this bucket, even if it was 10 feet tall, we would still be able to do it, but Math Dad would not be able to hold it up at that point because it would be too
I don't
heavy.
know. The chat was talking about how strong I was there. No, not everyone can hold up a bucket like that.
Not everyone can.
Yep.
All right. Let's do our third item pool question real quick.
All right.
And then we will go to our art project.
All right. So
sorry.
So our second question here. So what's the highest elevation a single person has gone to? What do you mean by?
Okay, by single person, I mean a person not in a vehicle. So if you were in a rocket, it doesn't count. If you were in an airplane, it doesn't count. It has to be a person who is not in some type of vehicle.
So mechanized.
Yeah, but you could jump out of an airplane, and that would count. So skydiving counts.
Oh, wow.
What's the highest that someone has ever been? And the top of Everest, just for scale, top of Everest is 8.8 kilometers. But the choices for the highest distance that somebody has traveled not being inside a vehicle, we have 16, 41, 52, or 90, is that 88 kilometers? That's quite the range. What do you guys think? What's the record?
That is a big range. Man, so the air is so thin up there. You'd have to have something special to help you breathe,
Oh,
right?
you definitely would. Even going to the top of Mount Everest, I highly recommend that anyone who does that has oxygen. There have been people who have made that trip without oxygen, but there's no question that their body suffers as a result. You're talking lots of brain cells dying because of the lack of oxygen, not something you want to put your body through.
Well, that's crazy. Crazy to even think about. All right, I think the votes are in.
Okay, let's find out.
Let's see what they said. So the most commonly chosen
Correct.
answer was
41 kilometers.
that was the least chosen answer. Actually,
Oh, that was the
Science
least
Bomb.
chosen? Oh, man.
They said
I was just looking at the
that's
green
the top
bar.
of Mount Everest. So wait a minute, you're telling me somebody got 41 kilometers up?
Yes.
How does this work?
It works because it's called space jumping. And there are a couple people who have space jumped, and the world record for the highest space jump is held by Alan Eustace. And he floated up into the stratosphere with a hot air balloon, basically, that was almost the size of a football field. So this was a huge record-breaking kind of scientific experiment where he jumped in a spacesuit with all sorts of, recorded data and took video on the way down. And it was from 41 kilometers. There's no way that you could survive without a spacesuit at that height because you were up into the stratosphere. The air is so thin and the temperature is so cold that you would freeze to death and die from lack of oxygen. But that is the record.
Okay, that's really impressive. Okay, and a cool fact here, getting into some math, there is something called terminal velocity, which is the fastest you can go because of the air will just slow you down after that as you're falling. And so interestingly, when you're that high, there's less air, so your terminal velocity would actually be faster. So you'd be falling faster up high, and then as you started hitting more and more air, it would slow you down. So you'd still be falling as fast as you could for the shape of your body, the air resistance that's there. But yeah, so you fell faster, and then slowed down a bit, and then I can't imagine stopping because you'd definitely reach your maximum speed.
You would. I saw several good questions in the chat about this jump. A couple about can we watch it? It was filmed, but the footage is not common domain. It's copyrighted footage, so we couldn't show it to you here in class today. But if you just search, space jump or Alan Eustace, search, the record for the highest jump or the longest free fall, clips will come up that you can watch, and you can watch the entire thing.
Wow.
It's about 4.5 minutes, I think, or 5 minutes of free falling, which is kind of remarkable.
What would you do falling for 5 minutes? That's crazy.
Look around. You'd have an incredible view.
Sure. Sing a few songs on your way down.
Speaking of songs, we have a song for you guys.
We do. So just let me jump back to the poll and show them what the last question was, because I know they will want to know, but we kind of spoiled it already. So
okay, real quick.
All right. So it was a question: will the egg experiment work if you use a water balloon instead of an egg?
And if you're better at this than Science Mom and Math Dad, the answer should be yes, but when we've tried it, it didn't work.
No. So I guess whatever you wrote, you could claim it's right, and we couldn't complain too much because
all answers are correct on this one.
Yep.
All right.
So I'm just going to reveal whatever I'd put right now and call an end to this one. So in theory, the answer, you should be able to substitute because the balloon makes a pretty good fake egg as far as this experiment is concerned.
Yes. Now, in the last couple classes, we have talked about the different layers of the atmosphere. And today we're going to show you several different ways that you could make an art project of the layers of the atmosphere. And we're going to share our first song of the class with you. We made a song about the layers of the atmosphere. So first, let's do our song, and then we're going to show you the different layers.
Okay.
So this song is sung to the tune of an old sea shanty called Wellerman. And apologies in advance if anybody has heard this song before and already has it stuck in their head, because it's a very catchy tune. Nice. And what we're going to do, we're going to do just the first 3 verses, and then we'll show you a couple art projects, and then we'll do the last 3 at the end. So first, of course, is for the Troposphere. Right. And I'm going to have Math Dad just sing along so you can hear the tune, and then I will join him with the chorus.
We live in the troposphere, bottom of the atmosphere. All our weather happens here in the troposphere. We love the atmosphere, keeps us safe and warm down here. 5 layers tier by tier in the atmosphere.
And now second layer.
Warmer than the air below, ozone layer had a hole. Airplane contrails white like snow in the stratosphere. We love the atmosphere, keeps us safe and warm down here. 5 layers tier by tier in the atmosphere.
And the last layer that we'll do right now.
Ever see a shooting star? The mesosphere is where they are. Coldest layer on Earth by far in the mesosphere.
Sing along.
We love the atmosphere, keeps us safe and warm down here. 5 layers tier by tier in the atmosphere.
Now, if you wanted to make a model of those 3 layers, and I should, real fast, sorry you guys, I forgot to share this link before. I have a link for you that has the templates that we're going to use today, and I emailed it to everyone who is registered for the class, and it also has the words to the song. So if you're thinking, oh no, I want the words to the song, but I couldn't write them down fast enough, fear not. It is in the description of the video and in the link that I just posted in the chat.
Right.
So if you wanted to make a model of the layers of the atmosphere, how would you do it? Well, there are several different ways. So one way that you can make this art project is to create a little series of semicircles. So this is a template that I made just yesterday because I thought it might be nice to have something a little more 3-dimensional. And we'll show you the handouts for that in just a moment. Another way would be to do it by scale.
So I'm actually curious, in your head right now, can you name those 5 layers in order? Take just a moment and try it, and then we're going to go over them because I think we need to repeat this to ourselves a lot. It's just not something that you came into the class knowing, most likely.
Definitely. And we'll go to the template in just a minute and show you, After, if you can pull that up. Okay. We'll show you this template and how you can put it together.
All right. So this is the bottom layer. So we got the troposphere, stratosphere, mesosphere. And then, so those were the 3 that we sang about already. And then last time we talked about the thermosphere and the exosphere. Yep. So those 5 layers of the atmosphere.
All right, let's go to the notes real fast and I'll show you this template. And then I want you guys to help me match the symbols. So we have a template here where you can see that there are semicircles for each layer. There's the stratosphere, here's the troposphere, and here's a little Earth that you can cut out. But what do we have here? We have some little symbols, and I'm curious, which layer do they go on?
Okay, so this one here, the airplane, what layer would that go on? So in the chat, type it in.
The airplane and this cloud represents, rain and weather. So what layer would that one go in? Science Mom Jody says, sphere-tastic. I love it.
All right.
So troposphere is correct. The weather, this all happens in the troposphere. And then for our plane, you have 2 options. You could say troposphere or you could say stratosphere.
No, so I think the cruising altitude is just into the stratosphere typically.
Most often.
Are you going to write the answer?
Okay, I'll write it real fast.
So up next, we got the space station. So in the chat, let us know what level is the International Space Station in?
And I'm going to write stratosphere for plane because right at the base of the stratosphere is where a lot of planes fly, but troposphere also works. Either one.
Okay. All right. I'm seeing stratosphere in the chat. Thermosphere, says Devin.
Correct. The space station orbits in the thermosphere, which the air is so thin it feels pretty much like space. Our ozone layer is in the stratosphere.
Stratosphere, okay.
And then this one is a little hard to tell what it is, but you can...
what is it?
It's supposed to be the aurora borealis. So if you had crayons, you could like color green up above these stripes.
So what layer are the auroras in? And
maybe it would look a little bit more like the aurora borealis.
I like that. Well, that would be the hardest thing in the world to draw. How do you draw an aurora?
It's very tricky to draw. So this one is mostly in the thermosphere as well, although
Yeah, Kristen's got it. Yeah, the thermosphere.
yeah, the altitude varies. So it depends on solar activity and where you are. It can be a little higher, can be a little lower, but thermosphere is the best answer.
Okay.
And then meteors.
Ooh, where are the meteors at?
Ever see a shooting star? The is where they are.
The mesosphere is where they are.
Mesosphere is correct. Whoops. And I have a difficult time spelling and talking at the same time. And then last but not least, we have the exosphere.
So that's where the most satellites are at.
That is where the satellites are. And again, if you would like to make this art project for the layers of the atmosphere, we have a template, and there's a link we just put in the chat. There's a link in the description. There's instructions right here, and then you can print out this page and another page that also has our two bigger layers, the exosphere and the thermosphere.
And also, you can get the words to the atmosphere song. We'll try to get some music posted at some point, but.
All right, let's go back to our main view real quick.
All right.
And I want to show the other art projects I made, because this is not the only one. This one's a fun one. Especially, I gotta say, my favorite part of this one is putting on our little symbols. So here I have my little shooting star. I'm gonna stick that right here in the mesosphere, and it's just kind of fun. You get to decorate. You get to decorate your layer however you want. Ozone layer is gonna go in the stratosphere.
I like it.
And ta-da! I have a little 3D art project. So the next version I made with no template, and you can do this too. And all you need is some unit. And that unit, whatever you choose, is going to represent 10 kilometers. And then you're going to make an atmospheric model that's somewhat to scale. You ready for this, Math Dad?
I'm ready.
So the unit I chose was Captain Crunch breakfast cereal, which is disgustingly sweet, way too sugary, but it's colorful. And so I colored my paper, and the first, inch or so is the troposphere. And you can see that my molecules of air, these representations of molecules, are really close together.
So it's really thick air.
Yeah, thicker air in the troposphere. And then in the stratosphere, things get further apart. I colored an orangish stripe, reddish stripe for the ozone layer. And notice I've got lots of blue because that's my nitrogen, a few greens, that's the oxygen, and then just one little argon here, because argon's only 1%. And then I put one carbon dioxide molecule as well. But the carbon dioxide molecule, really, if I wanted to be accurate, I would have to have several hundred of these papers, because carbon dioxide
to have just one carbon dioxide molecule? Wow.
0.04%. That's a very small amount of our atmosphere.
Wow. So that's 4% of 1%.
Yes.
That's really tiny.
But this isn't the only version I made. You want to see the next one?
Ooh, I'm ready.
So here, I decided that it would be pretty cool if I could have one breakfast cereal represent 10 kilometers. There's the troposphere. And then 40 kilometers, that on average is the stratosphere. Here's the mesosphere. And now look how big the thermosphere is by comparison. Whoa! And if you think the thermosphere is big, look at the exosphere. More than 500 kilometers in height. I ran out of kicks.
This thing's taller than me.
It is. It is. So you can even make it model to scale like that if you would like. And last.
That's the only time Science Mom ever buys Captain Crunch. It's an art project.
This is true. And then last but not least, we also have a template where you can make the layers of the atmosphere using letters for art. So we have T's interlocking here for the troposphere, S's interlocking for the stratosphere, and M's interlocking for the mesosphere.
Real fun. So those templates are...
Those templates are all in the description, and I emailed them out to everyone registered for the course, and we would love to see what you come up with. So I hope you will have fun creating a project and then share it with us. You can email us a photo, or you can post it on social media and tag us. We would love to see your art.
And yeah, so there was just no way we were going to be able to get through these projects today, but we wanted to make sure that we just showed you what they are, because they're really fun projects, and they take a lot of time if you want to make them look nice.
They do. So I didn't feel like we would have time to actually do all of the coloring or cutting things out in class, but I wanted to make sure that we shared them. And now we're gonna
sing the other two.
We will sing the other two verses, but I want to answer some questions first real quick. So Remington Wolf asks, if you remove all the air from space, then what would replace the air? So, and this is a good question. It's something that I'm glad to touch on again. So when we are down here in the bottom layers of the atmosphere, there's a lot of air. But as we go up into space, the air gets thinner and thinner. And in the thermosphere, where the International Space Station is orbiting, most of the space is just that. It's space. It's emptiness. And if you were able to go down to such a small level that you could actually see atoms, you would see that in between atoms, even in something solid like a block of gold, in between atoms, there is empty space. Inside atoms, there's also empty space. And out in outer space, there is a lot of empty space. That's really what space is. It's a vacuum of nothing.
So once you get high enough, the molecules aren't even interacting with each other because they're so spread out?
That's right. In the thermosphere, molecules are not bumping into each other. Each one is kind of on its own path. And some of them actually get thrown out to space. Our atmosphere is leaking a little bit of gas every year. All the time it's losing just a tiny bit of gas because some of it's going out into space. But then meteors are entering, tiny little shooting stars and things are entering our atmosphere. And when they burn up, they actually add a little bit to our atmosphere as well. So there's sort of this balance back and forth.
Interesting.
And got a great question from Sanya and Kim. If you used a bigger bucket, you'd be able to hold more water. True. Although a bigger bucket gets a lot heavier. But it's the if your bucket is more or less a cylinder where it's just straight up and down, then the thing that determines how much water you can hold is the height. And you have to get really tall before the weight of the water is more than 14.7 pounds per square inch.
So this bucket could be taller than our house, right?
In theory. Yeah. Although the other part of that is that the board on the bottom can't be too heavy. If we had filled up our bucket with water, and then if we had put a big piece of plywood over the top, the plywood,
it weighs a lot.
Might weigh about 10 pounds. It's the weight of the plywood now plus the water. And so a really heavy lid will add to that weight and make it fail sooner.
Really cool.
And then another good question. Aaron Knowles Millie asks, what's the highest a bird has flown? There have been birds that have been reported to fly over the Himalayas. And I think that they've been sighted as high as 30,000 feet. And I'm not entirely sure on that. I would need to fact check and do some research to be sure what the record is. But I know that there are some migratory birds that fly over the Himalayas. And granted, they're probably not being like, let's see how high I can fly. They probably choose the mountain passes rather than going over the peaks.
Science mom Amber here actually came up with an answer. Checked it on Google and said the Ruppel's griffin vulture, 37,000 feet.
Oh, that is high. Oh my goodness. I'm impressed. And
thanks, Amber.
Another last question from C. Kess. How does our atmosphere stay around our planet? And how do we get our blue sky? The answer is gravity. Gravity is what keeps our atmosphere around our planet. So there is this force pulling in that keeps the air on our planet. And the air that is on the bottom of the atmosphere actually has weight of the air that's on the top, sort of pushing down. And that helps to keep it around the planet as well. But gravity is the main answer. And then why is the sky blue? Mostly it's because of oxygen and nitrogen and how they interact with the sun's light in the upper areas of the atmosphere. And it turns out that blue is the blue light radiation is kind of bounced back and reflected. That's why our sky is blue. Good questions, you guys.
So someone was asking about the hole in the ozone layer. Are we waiting to answer that one for another day?
Yes, we'll save that one for another day. We have a whole lesson on the ozone layer.
Somebody asked if they could get a sweatshirt like you.
Oh, yes. We have a Teespring store that is somewhat under construction at the moment. Next week, I will send out links in the email. Okay. But this is our testing phase. We are ordering different designs and then testing out what works and what doesn't. Good questions. All right. And then I saw someone ask, send the art templates. I'm going to paste that in the chat again. So this link that I just put in the chat, that's where you can get the art templates. You can just download them.
If you refresh, it'll be down in the description.
Yep. Are you ready for the song?
I'm totally ready for the song.
All right. We are going to sing the next 2 verses of the song. You guys are welcome to join and sing along with us. We're going to sing about the exosphere and the mesosphere.
No. The thermosphere and the exosphere.
Thank you, Math Dad.
In that order.
Thermosphere and exosphere.
Maybe. No.
Whoops.
No.
Oh no.
There you go. Okay.
There we go.
Molecules extremely hot, radiation ions brought, space station for astronauts in the thermosphere.
We love the atmosphere, keeps us safe and warm down here. 5 layers tier by tier in the atmosphere. The exosphere is way out there, nearly space, it's such thin air. Satellites are everywhere in the exosphere. We love the atmosphere, keeps us safe and warm down here. 5 layers tier by tier in the atmosphere. Yay! We hope you guys enjoy that atmosphere song, and I hope it helps you remember the differences between the layers.
That's definitely my challenge for you guys. We've been talking about them for a few days, and I think the names are starting to stick. But by next week, when we come to class, I'm hoping that every one of us will have those 5 layers memorized in order, so bottom to top. And then if you can remember the things that are special about them, I think the art project will help with that. Well, like, oh yeah, it's like this must be where the International Space Station is. Oh, here's where the ozone layer is at.
Exactly. Have fun with the art projects and definitely share it with us. So if you can send us pictures by email or put on social media, we would love to see them. And then the very last thing I have before we end class today, I want to go to page 11 of the notes and show you guys how we tell the difference between the different layers, because it's really all about temperature. And we've talked about how the height of the stratosphere changes based on the time of year and based on where you are in the world. Sometimes it might be you go up to 10 kilometers and there's the stratosphere. Other times it might be a little lower, it might be a little higher. It depends on the weather. But how do you know if you're in the stratosphere?
I don't know.
The temperature.
Oh.
The temperature is what tells you, because when you're in the troposphere, the higher you go, the colder the air temperature gets.
Wait. Okay, so on this vertical axis, so this is the altitude axis. That's telling us how high we go. And on this horizontal axis, we're seeing the temperature. So temperature rises as we travel further to the right.
Yes.
And temperature's dropping as we go further to the left.
Yes.
Okay.
So right here, this is negative 60 degrees. That is super cold. 60 degrees below 0 Celsius. That is incredibly cold. And when we get to the top of the troposphere, we're approaching negative 60 degrees.
Ooh.
That is incredibly cold. And then it's very linear, where every 1,000 feet, the temperature drops, and it drops the same amount. And all of a sudden, right around 10 kilometers, the temperature stops dropping and it stays the same. This is called the thermopause. And it's the boundary between the thermosphere and the stratosphere.
It's like somebody hit pause on the temperature dropping. Like, whoa, let's pause that for a moment.
Exactly. And then the temperature starts to get warmer. And this is what defines the stratosphere.
Wait, why is it getting warmer?
It's getting warmer because of the ozone layer. And you might have remembered from other things that we did that our ozone layer is actually right around, I thought I had a highlighter, but I didn't. Our ozone layer is around here. So if the ozone layer is, I drew it in the wrong spot. If our ozone layer is here, then why is it warmer above it? Thanks, Math Dad. Math Dad saved me. So there's our ozone layer, more or less, but the warmest temperature is up above, and this is because heat rises. So the ozone layer is what's warming that entire layer of the stratosphere. And then up here, we have another pause called the thermopause. And then in the mesosphere, things get really cold. And up at the top of the mesosphere, these are the coldest temperatures on Earth. Well, they're kind of above Earth, but you know what I mean. Negative 94 degrees Celsius.
Crazy.
And then when we get to the thermosphere, it does the opposite, where it gets warm again.
So this is kind of cool. You said at the top of the troposphere was the tropopause. At the top of the stratosphere was the stratopause. At the top of the mesosphere is the
mesopause.
Mesopause. I like that.
But that is why we have different layers of the atmosphere, is just because the temperatures change, and that change in temperature is pretty important. It tells us a lot about how that layer of air is going to behave. Because in the troposphere, you have all this mixing. That's where the name tropo comes from. It means mixing. And it's really a dynamic layer where everything's changing. There's weather happening all the time. In the stratosphere, that layer is pretty stable. there's not a lot of change. There's not any turbulence, and it is more or less stable.
Sengren Kim asks a really interesting question. So why is there no gravity in space? And this might not be the direction we wanted to head, but it's kind of weird, right? Because shouldn't we be pulled down towards Earth?
This is more of a discussion for a physics class, but gravity is so cool, you guys. Gravity is the attraction between objects, and it turns out that there is gravity everywhere, but we feel gravity when we're close to something really big, like the Earth. And when we get far enough away from the Earth, then we don't feel its gravity anymore.
But the reason that on the space station, they're not feeling gravity, they're actually falling. But they're falling at a way that they're actually falling around the Earth, and they just keep missing the Earth. It keeps falling over and over, but it just never hits it because it's falling sideways.
Yeah, being in orbit is pretty cool.
Yep. All
right, let's head back to the main view really fast.
Oh.
And one more really good question that I saw that came in. It is the moon in the atmosphere? This is a really good question. And it turns out the moon is not in the atmosphere, even for people who count the exosphere as far as they can, like just, one molecule of air from Earth every 3 or 4 kilometers. Even if you go to that definition, the exosphere at the biggest gets to about halfway between Earth and the moon. But most scientists say, no, it doesn't go halfway to the moon. It's a little bit less. But the moon is not in Earth's atmosphere.
That's a good question.
But the moon has its own exosphere.
Oh.
There are just just a few particles of gas around the moon, and they call it an exosphere rather than an atmosphere because it is so thin. You wouldn't know it. If you step out of your spacesuit, it's going to feel just like a vacuum. But there are a few gas particles around the moon.
So we were just kind of taking it for granted that we have an atmosphere. You're saying other planets or the moon doesn't even have an atmosphere, or maybe nothing more than a few particles.
Yeah.
Wow.
Yeah, there are a lot of planets that don't really have atmospheres. They just have either an exosphere, a very small, smattering of a few particles, or they have no atmosphere at all. All right, you guys,
Somebody is totally asleep in my arms.
Oh, Science Puppy did fall asleep completely. That's rather adorable. All right, we are out of time, but I hope you guys enjoyed learning a little more and having this review about our atmosphere and the layers. And we hope you will do these art projects and show them to us because we would love to see your work.
Yeah, well, really curious what you're going to come up with.
Yeah. And last but not least, we have some birthday shout outs. So a big happy birthday to Lydia, who turned 7 yesterday, to Max, who's having a birthday tomorrow, to Landon, who turns 7 on the 24th, and a special shout out to Nicholas. I hope that you guys have a wonderful day, and we will see you on Monday. Work hard, grow smart. We'll see you soon.
Bye.